Hey you guys, this is your second video for 6th grade science. So if you're keeping track, we're on week 25. Wow, it's windy today. I just came in from the wind. So welcome. Today we are going to, today's lesson is actually a little shorter. A lot of what we're going to do as far as experiment wise is going to be on you at home. So let's just do a quick review. This will be the last week that we talk about energy and matter. For the last 2 weeks, we've definitely focused on heat transfer and all of the aspects of that. So I want you to remember some of those terms: conduction, convection, radiation. Remembering that something that is hot, when it's transferring, it wants to have an equilibrium or a balance between the hot object and an object that is not as hot. It wants to have a balance between the two. So think about that. I'm going to give you a little scenario here real quick, but our last thing that we're going to talk about as far as heat and energy transfer has to do with conductors and insulators. Look, I have a super high-tech conductor, or I have all my props here, or an insulator. Peekaboo. So conductors and insulators. Can you see those? These are the two terms that we're going to talk about today. So if you had to define conductor and insulator, I want you just to think about it for a second. You don't even need to push pause, but think about what those terms mean as far as heat or energy transfer. I'm going to give you a scenario, and I'm going to see, this is where all my props come in. You're going to see if this makes sense. So here's your scenario. You and your family, it's a beautiful, clear, snowy day, and you've decided that you want to go snowshoeing. So things have calmed down. It's a great time. You're going to go get all ready to go. Your assignment is going to be to transport the hot chocolate for the family. So everybody, hot chocolate after an hour or so snowshoeing, doesn't that sound good? You know, it doesn't sound good. Cold hot chocolate, cold chocolate. So you are in charge of getting the hot chocolate and having it stay warm. So when we are talking about insulators and conductors, what do you think that you might use to transport the hot chocolate? Some substances are going to be better insulators and some are going to be better conductors. Now, I'm going to show you a video in a second that's going to give you a couple of keywords, because it's always more fun to watch just a fast video than to watch my face. But so you get in the cupboard and you pull out a water bottle made of plastic. It does have a lid, so you'd be able to transport the hot chocolate. How long do you think the cocoa is going to stay warm if you carry it around in a plastic bottle? Okay. You keep looking around and you find a ceramic mug. Now, at home, if you were going to have hot cocoa, this is 99% of the time what you're going to go for, right? Actually, look how cute. Do we look the same? You don't have to have a Winky mug. You can just have any kind of mug. It's ceramic. How is this as a conductor or an insulator? Now, one problem could be that you're not going to be very easy to keep it from spilling, but think about what it's made of, the material. So still looking around and you come across this. Whoa, sorry. What about that? Can you see it? Oh, there we go. What's that? What is that? Now, we use this one for soccer games, and I don't typically take hot cocoa to soccer games. Sometimes we do, though, because when it's 12 degrees outside and they're still playing soccer, a hot cocoa sounds great. But what's different about this than our water bottle, our regular plastic water bottle, and our ceramic mug? What's different? What material is this made out of? Now, it's plastic, but the key is what is on the inside. What's between your liquid and the outside? What's the word I'm looking for? This is insulated. This is a thermos, and it's an insulator. So this would be an excellent option for you to take your hot cocoa out. It even has a handle. So Insulators, when you think about it in the transfer of energy and heat, some things are going to be better than others. Let's watch this quick video and I'll kind of talk over it. Where is the video? Oh, there's some info on heat transfer, not that. Let me find the video here real quick. Okay, here we go. Isn't this fun? Just never know what's going to happen. I might knock the computer off the desk. I might drop something in my lap. Here's just a really quick, some visual or a visual to help you with this. So conductors and insulators, what is the difference? So now we're talking about materials. What makes a good conductor? A conductor is any material that allows energy to flow. So we're talking about heat, we're talking about electricity. What are some examples of a good conductor? Now, if I paused you right there, we think about it for a second. If you needed to have the energy or heat flow go more rapidly or easily, what would you use? Let's see if you had some of the same ideas that we get in the video here. Metal, copper, cast iron, conductors. We use metals to make objects that need to conduct heat well. So when you use a saucepan on the stove, it's going to conduct the heat very well. It's going to make the food heat up quickly. Is metal the only material that can conduct energy? Nope, water can conduct electric energy too. It's very loud. All right, what is an insulator then? So we know that a conductor is something that allows the flow of the energy or the heat. So an insulator would do the opposite. Material that does not easily allow energy to flow. So what would be some good examples of an insulator? Think for just a second. I'll stop this groovy music. What do you think would be some examples? Now, we pulled the thermos out. What's in the thermos? What kind of insulation? What kind of materials would be good insulators? We saw that metal is going to be a good conductor. So you're probably not going to want to insulate something with some copper. Let's see what some examples are. If you thought of a few, let's see if you thought of these. Are you guys snapping your fingers? I am. Rubber, wood, fabric. This brings up an interesting point. When you guys were getting ready in that visual of going on your snowshoe adventure, what did you put on when we go outside? If we're gonna wanna insulate ourselves and keep our body heat with us and not let all the body heat out, what are some things that you do for yourself? Throw on a coat, put on a couple pairs of socks, stocking cap, gloves, snow pants. You're insulating yourself. You probably wouldn't want to put maybe a good conductor of the heat, let the heat out, or not cover up and have your body heat insulated. So a definition for an insulator or a good insulator might be wood. So I like this, you know how obviously we love to talk about cooking when we're talking about heat transfer. We talked a lot about cooking. But when you guys are making your macaroni and cheese on the stove and you need to reach in and stir it up, have you ever gone in with a metal fork or spoon or some tongs and left it in there a little too long? What happens to the metal tongs or what happens to the metal spoon? Does it start to heat up until you're holding it with your hand and you kind of can't touch it anymore? Have you ever left a spoon, a metal spoon, in maybe some sauce or something that's on the stovetop and walked away and come back and grab it onto your hand? I have. Not very smart. It's hot. That metal is the conductor. It pulled the heat right from the pasta water or the sauce or whatever you're making, right through that metal conducted the heat. And then when you touch it, it burns your hand. That's why wood is a great insulator, and that's why we have wooden spoons a lot of times when we're cooking, and then other things like plastic and some other materials that would be better insulators than conductors. So it's a really good visual for you. Nobody wants to burn their hands. I don't. Oh, well, and thank you for watching. We thank you too. I like that. Just gives you a kind of a couple of things to think about when you're talking about conductors and insulators. So what you're going to do today is, like I said, it's going to be all you. You need to you're going to do some experiments, and I want you to, it's going to be in two parts. The first thing that I want you to do is I want you to think about what would make good insulators by creating, designing your own thermos. So I don't need you to physically make one. If you can and you have the supplies around necessary, available to you, and you have the space and permission, go ahead, let's make one. This is what we would have done in class. But what I want you first to do is, there'll be a page listed in the optional supplies where you are going to design your own thermos. So it needs a few things. What I want you to do is I want you to really think about it. I want you to think of three to five materials that you think would be good insulators. Now, the video gave you the example of wood, rubber, and fabric. What else do you have around your house that you think might be a good insulator? Start thinking about how do you keep things cold in the fridge? How do you keep things hot other places? What kinds of materials are being used to be an insulator? Because actually, we've talked about it with heat transfer, but insulators, how many of you guys, when you bring your lunches to school, are trying to keep your little fruit cups and your ranch dressing and your drinks cold? Is insulating useful to keep the cold in as well? So you're stopping the transfer of energy. It doesn't always have to just be heat, it can be the energy. So what kind, I said fabrics, what kinds of materials would be good insulators? So I want you to look around your house. I want you to think, and I want you to list between 3 and 5 materials that you think would be good insulators. Then I want you to sketch it out. You're going to be the engineer. You're going to draw it. I want you to put a design down. How would you do it? What would be your inner vessel? What's going to insulate around the inner vessel? What would your outer vessel be made out of? What would it look like? How would you design the lid? Because you can have the best insulated cup. I mean, that's kind of like this kind of thing, the thickness, but if you don't have something to keep the heat in, it's kind of like putting a stocking cap on your head. The heat's just going to go right out. So you've got to think about all of those things. How are you going to put it together? If we were in class, we would probably use supplies, tape, hot glue, string. What do you have? What do you think might be a way that you could design that? So assignment number 1, and this is what you're going to use your paper and pencil for that you always have handy. I want you to write down 3 to 5 materials that you think would make good insulators. And then I want you to design a thermos of your own. What would it look like? What size would it be? How are you going to put those things together? What is going to be, I just have to look real quick. How are things going to be positioned? Are you going to layer things? Are you just going to use one material? Or are you going to layer several? You can design a couple if you want. Maybe this one was made out of this material. This one was made out of this material. So that's assignment number 1, is to design your own thermos. Now, if you are in a position where you can experiment with that thermos, you've gone around and looked for some household supplies and they're available to you and you might want to experiment with it, great. You have to have permission from parent or whoever is with you. Parent. You need to have permission before you start messing around with household supplies. I will list what some of those could be on the optional, on a document. So if it's something you want to prepare ahead and you do this together as a family or maybe with some siblings, that would be great. This is a perfect place that I want you to take some pictures and send me some emails with notes on what you found or what your thermos design looked like. Take a picture of it and email it to me, or describe it and email it to me. I want to see these. Then experiment number 2, I'm going to send you 2 videos that are a little easier to have a hands-on experiment. Said that word. You know what? I get tongue-tied a lot. It's kind of embarrassing, but actually I think it's kind of funny. So what I want you to do is you can watch either of these videos. If you can't physically do an experiment, these are great videos that give you an idea of different things, different materials that might make a better insulator. And you can make predictions, and then you can do the experiment, and then I want you to give me your results. So if it's something you can practically do, you can actually physically do it, great. If you can't do it, watch the videos and kind of test yourself and say, oh, okay, I think for this one, that's going to be the best insulator, and jot it down and then watch the video and see what you think. So this lesson today is kind of up to you and what you're able to do, but super interesting to think about what kinds of materials are good insulators. What would you use if you were in a pinch to maybe keep something really hot or to keep something cold, keep it cool inside? So check the list for all of those links and those worksheets, papers, and then be sure, for sure, to email me with what you found, with your results. Okay, so good job, you guys. And next week we will move on to a different unit. So we'll leave energy and matter behind us. And parents, watch for an email. I will send you some additional links of videos and things that you can watch that kind of follow up with our last few weeks of energy and matter. So I hope everybody's doing good. See you next time. Doing well. I hope you're doing well and you're happy. See you next time.